When heavy industrial machinery grinds to an unexpected halt, the immediate financial loss of unplanned downtime is compounded by severe physical risk to operators. The traditional response to these bottlenecks relies on break-fix maintenance and siloed training modules. Operations directors attempt to plug the gaps with isolated software tools, but those single-point solutions fail to prevent the next unexpected failure. Integrating a new class of spatial and predictive computing yields exact operational countermetrics: a 48% drop in safety incidents, a 37% reduction in mean time to recovery, and a 2.7x total return on investment. Achieving these exact numbers requires moving away from disparate safety and maintenance tools. Instead, the facility must be rebuilt on a unified, three-layered technological architecture. Let's build this VirtuoniX framework. Layer 1 is the predictive foundation, machine learning sensors on the floor forecasting mechanical failures. Layer 2 is human readiness, safe environment hazard simulation rooms for VR operator mastery. Layer 3, an augmented reality network connecting floor workers with remote technical experts. That 2.7 times return on investment happens because machine forecasting, operator readiness, and expert networks operate as a single continuous ecosystem. We drop down to the machine level on the plant floor. Here, the primary operational directive is simple: identify the mechanical failure before it actually stops production. We retrofit critical machinery by deploying VirtuoniX smart sensors directly to specific vibration, heat, and output points. These sensors establish a continuous data flow into the VirtuoniX ML Health Score engine. The machine learning engine analyzes that data. Upon detecting an anomaly, it triggers an actionable response, automatically scheduling maintenance in your CMMS and initiating a just-in-time parts order workflow. Compare this to the traditional break-fix model. Instead of waiting for a gear to snap and halt the entire line, the system resolves the vulnerability while the machine is still running. We can measure the precise impact of this predictive layer by examining a recent deployment at a large-scale manufacturing plant. By utilizing the ML engine to continuously optimize parts planning and auto-schedule maintenance, the facility prevented major catastrophic equipment failures over the entire operational period. Integrating machine learning forecasting directly at the baseline machine level resulted in a documented 30% reduction in total facility downtime. But predicting mechanical anomalies is useless if the human operators on the floor aren't adequately trained to handle them. The system requires human readiness. This schematic details the hardware behind VirtuoniX industrial skilling. It is a 6 degree of freedom motion platform rig, specifically designed for heavy machinery simulation. These motion platforms are paired with photorealistic physics engines. This combination precisely replicates the physical sensation and mechanical feedback of operating excavators, cranes, trucks, and forklifts. The core pedagogical advantage of this system is a feature called dynamic scenario injection. During a routine simulation session, instructors can instantly introduce complex variables. They can trigger sudden equipment failures or violently shift the weather, like a heavy rainstorm that severely blinds the operator. This carries massive safety implications. It allows operators to practice their responses to high-risk catastrophic emergencies in a virtual environment where physical risk is removed from the learning process. To quantify the real-world impact of this methodology, we look at a global mining company that implemented VR training for its heavy equipment operators. Inside the simulation, the system runs real-time performance analytics on the operator's reactions. Instructors use these precise analytics to pinpoint specific weaknesses, leading to faster certification and drastically improved baseline safety scores. By moving training out of the physical yard and into high-fidelity simulators, the company removed the risk of accidents during operator instruction, while driving a 75% reduction in total training time. Even with predictive maintenance and rigorously trained operators, facilities still experience the final operational gap: live, unpredicted mechanical faults that require immediate, highly specialized off-site expertise. To solve this, VirtuoniX deploys the Expert Guidance Platform. This is a networked solution built to connect field workers directly to technical experts, regardless of their geographical location. When a live crisis occurs, the system utilizes LiveLink augmented reality to bridge the physical and digital divide. Off-site experts use this spatial collaboration tool to see exactly what the operator sees. They can project digital annotations onto the live feed, guiding the floor worker step by step through complex, unfamiliar repairs. For non-critical faults, the system utilizes Ask Ava AI chat and SmartTickets automation. This provides an immediate, searchable retrieval system for the facility's institutional knowledge. Combining this on-demand AI retrieval with live AR guidance allows facilities to successfully resolve 75% of all maintenance issues without ever requiring an expert to travel on-site. The ultimate high-stakes stress test for this remote intervention system occurred on an offshore oil and gas platform. In an environment where dispatching a specialist requires helicopters and days of planning, the platform entirely eliminated expert travel costs and the associated logistical downtime. Because they routed all diagnostic expertise exclusively through the AR spatial network, the platform also measured a significant improvement in its first-time fix rate. By bringing the expert's eyes to the problem instantly, this AR network layer cuts mean time to recovery by 37%, ultimately delivering a 60% faster total incident resolution rate. Zooming out to view this architectural stack running simultaneously, the VirtuoniX ecosystem operates as a unified nervous system. This creates a continuous feedback loop. In Phase 1, machine learning sensors detect and log a novel mechanical fault on the floor. In Phase 2, that log data automatically updates virtual reality training modules, so operators can immediately practice handling the exact fault in the simulator. In Phase 3, remote experts utilize this historical data to rapidly resolve future live anomalies via AR elsewhere. Predictive data prevents baseline downtime. VR simulation builds physical readiness. AR networks guarantee live fault resolution. Deploying this holistic system yields aggregate facility-wide results, a 48% drop in overall safety incidents, and a 2.7x total return on investment. For plant operations directors, the final barrier to entry in adopting these technologies is typically the fear of long implementation timelines and operational disruption. However, the VirtuoniX suite is built around a rapid deployment cycle. A fully customized system can be integrated, calibrated, and reach the pilot phase in under 6 weeks. To select the exact immersive, remote, and predictive capabilities required to hit your specific facility performance goals, schedule a targeted live demo with VirtuoniX today.